afternoon to Dr. Shanur Shantel, and I will be presenting our project, DSP Digital Signal Processing, BEP 30503. And my group members are here, 5 of us, Muhammad, Fikri, and Efa, Aida, Amzani, and I, Abdullahi. And this is the introduction part, which means that this project we will be dedicating to the knowledge of digital signal processing to analyze and process the given signal by using MATLAB software. We are also required as well to design filters to perform some specific requirements, such as using the digital filters to remove the output signal surpass or below to a certain amplitude. There are some important terms that we need to understand in advance before doing this project, which are discrete Fourier transform, which is in a short form of DFT, and finite impulse response in a short form of FIR, which filter infinite impulse response, IIR filters. And these are the objectives that we required in the group. To study the discrete Fourier transform would be our first major. To investigate the signal by using the techniques of discrete Fourier transform in a short form of DST. To expose students designing the digital filters, finite impulse response and infinite impulse response as well. To learn using MATLAB software for simulating the output signals.
My name is Nurul Aida Azra Zahan, CE150245. Today I will present about the methodology. This methodology was combined 3 questions. For the first, this is for the first question, that is 300 signal frequency input, and our group was get the signal 4, and then we need to analyze signal using the discrete Fourier transformer DFT. If we get the magnitude and the phase that we need, so we can to proceed to the second question, that is design finite impulse response filter, and we need to remove the component axis amplitude of 50. Then we need to analyze the filter signal using the DFT. If we get the phase and magnitude, we go through to the third question, that is design the infinite impulse response filter, and we need to remove component with the amplitude of 50 or less, and analyze the filter using Fourier transformer.
I will explain about the result and analysis. For question 1, this is a coding for question 1, and then this is a signal 4.tag is a sample frequency that I have saved at Notepad. So then this is a coding for a calculation that will be kept for DFT technique. Then this is a result. So that is not clearly, but I will show it. Will continue about the in MATLAB. So in my part is question 1. So this is a coding that I have said before that. This is a signal 4 that we save in Notepad. So our group is signal 4 that will be given by the lecturer. Then the result is then we must first we must tagging magnitude at each of the magnitude. The magnitude show 150 because it is a mirror. For this and this is a mirror. Then the total frequency is 300, but the result showing is half of the 300, which is 150. So the first for x and y, x is the range and y is the amplitude. So the x for the range is 70, 31, 46 and 65. For the amplitude is 125, 40, 41 and 415. This is for range that we will use for question 1, question 2 and question 3. So for the phase, we take the highest and the lowest value. This is x65 and y negative 0.01, and for the x is 132 and y is 0.009. This is the value, the highest and the lowest.
I'm Fitri, so I will proceed the question 2. Okay, for this question 2, we will using the finite impulse response FIR filter to analyze that signal that we already get. Okay, so in this calculation or in this MATLAB program, we use the frequency is 60, and this is the range that we already get. This for half period. 26 over 150 and 50 over 150. Actually, for one period, it will be 300 over 300. That will be equal in one period. So this is all the command that to calculate the inner mathematical in MATLAB. Okay, so we can see here the result, and for the result we divide into. Firstly in the magnitude, secondly in the phase. Okay, for the more detail, I will show in the MATLAB. Alright, I will continue in MATLAB. So this is the coding for question 2 for FIR, finite impulse response. So just like you see this, the coding in MATLAB, and then after we run, we will get the result in phase and also in the magnitude. Okay, so here for the magnitude, we will see that the result show in a band pass. Actually, the result. Okay, so in band pass, we will get the lower frequency and the higher frequency. So the lower frequency, it will be here, because in theoretical, for calculate the for know the point of the lower frequency and also the high frequency, it will be a negative 3 dB. So the we mark here. Here we get the lower cut-off frequency, and here is high cut-off frequency. Okay, after we run this, we will get the result in magnitude and also in the phase. Then we run this section. So we get here. Okay, for this result, we will show first in magnitude and this phase. This result show in a band pass filter signal. Actually, for band pass filter signal, we will we can get the high frequency and also the lower cut-off frequency. In theoretical, for band pass filter, we will get the value here. Actually, the level of cut-off for band pass filter is here negative 3 dB. This value in dB. So here we get the value of cut-off frequency. X is 0.166 and Y is negative 7.969. For the highest cut-off frequency is X 0.3379, and for Y is negative 7.216. Okay, for in a theoretical, we will drag here and down, and using this result, we can know the range of this value of this. We using a high frequency will minus lower frequency. Then we will see the value here, because in band pass we want to know the we will call area here. Actually, okay. So this in the phase result, we will get the highest phase and also the lowest. For the highest, we get X is 0.1055 and Y 245.4, and for the lowest we get here is 0.3984 and Y is negative 1073. Okay, for the question 3, in this question 3, we need to use the technique in infinite impulse response IIR filter. Okay, in this technique, also use the frequency is 6, and then the range that we get, that we choose, is 26/150 and 45/150. This we do this in a half period. Here is the calculation, mathematical calculation that we create in MATLAB. After this, we already need and run the simulation. And then we also get the answer, the result also in a magnitude and also in a phase. Okay, for the magnitude, we can see here this result show in a band stop filter. Actually, the signal show in a band stop filter. And then here, the formula is same actually. With this result in magnitude, we can get the lower cutoff frequency here and a high frequency in here. For lower cutoff frequency, we get the value is X 0.1738. For Y is -3.287, and for the high cutoff frequency is X 0.2988, and for Y we got the -3.439, and here we got the lower. Here is 0.2305, and the Y is -196.2. And for the result in phase, here we can see that the response from the magnitude result, we can see here this phase respond in with the result in a magnitude. You can see here from this magnitude we get phase in the highest and the lowest. For the highest, we get the value is at 0.2324 and Y is -189. For the lowest value is we get X equal to 0.2266, and for Y is -528.4.
My name is Yusriana binti Riandra, CE 150248. Okay, today I will do the conclusion for this group project. Okay, first of all, I want to say that we are able to learn how to use software MATLAB, which is we able to solve this problem by using MATLAB simulation. And after that, by using software, the result on the magnitude and spectrum are able to analyze. Okay, so I want to do a conclude. Just we use the technique which is DFT, discrete Fourier transform. Which is DFT is more easier if you want to compare to discrete time Fourier transform, DFT. After that, we also able to design finite impulse response filter to remove the unnecessary component signal which is exists until amplitude 15. Okay, IIR is a property applying to many linear variant system. So I can say that is vice versa to the FIR. So that's all the conclusion that I can do. Like my other members say that the range for question 1 is 31 until 45, and then the question 3 is 70 until 65. Okay, that's all from me. Thank you.